Welcome to Sleepy Science, a place where curiosity slows down and the universe unfolds gently in the quiet moments before sleep. If you enjoy calm journeys through knowledge, consider liking the video, subscribing to the channel, and sharing in the comments where in the world you are listening from tonight. Somewhere on Earth under the same sky that has inspired humans for thousands of years, a sky that holds the soft glowing river of light known as the Milky Way. Above our planet, far beyond the clouds and the quiet blue atmosphere that protects us, there exists a vast cosmic structure that has been slowly forming and evolving for billions of years. This structure is the galaxy we call home, the Milky Way, a colossal island of stars drifting silently through the darkness of space, containing hundreds of billions of stars. Enormous clouds of gas, invisible fields of gravity, and countless planetary systems, each quietly orbiting their own stars in distant regions of the galaxy. If you could step far away from Earth and slowly drift outward through space, leaving behind the orbit of the moon, then the planets, and eventually the distant icy edge of our solar system, you would begin to see something remarkable. Our sun would become just another small star among many others. And gradually, a vast spiral structure would begin to appear around you. A massive rotating system of stars and cosmic material stretching across unimaginable distances. This structure is the Milky Way galaxy, a cosmic city of stars slowly turning through space, shaped somewhat like a giant spiral disk with long curved arms made of stars, gas clouds, and glowing nebulae that wind outward from a bright central region. The entire galaxy stretching roughly 100,000 light-years across, which means that even light itself, the fastest thing in the universe, would need 100,000 years to travel from one side of the galaxy to the other. Inside this enormous structure, there are thought to be between 100 billion and 400 billion stars. Astronomers cannot know the exact number because many stars are hidden behind dense clouds of dust and gas. But even the lowest estimate is almost impossible for the human mind to imagine. If you counted one star every second without stopping, it would still take thousands of years just to count them all. Among those billions of stars is a very ordinary one, a calm yellow star that we call the Sun, located not at the center of the galaxy, not near the outer edge either, but somewhere in the quiet middle regions of one of the spiral arms, a peaceful neighborhood far away from the chaotic and energetic center of the galaxy, where stars crowd closely together and powerful gravitational forces shape the surrounding space. The Sun, along with all the planets of our solar system, is slowly orbiting around the center of the Milky Way, moving through space at an enormous speed of about 800,000 kilometers per hour. Yet even at this incredible velocity, the journey around the galaxy is extremely long. One complete orbit takes about 230 million years, which means the last time the Sun was in this exact position within the galaxy, dinosaurs were still walking on Earth. From our perspective here on Earth, the Milky Way does not look like a spiral galaxy at all because we are inside it. Instead, when we look up at the night sky from a dark location far away from city lights, we see a pale glowing band stretching across the sky, a faint misty river of light made from the combined glow of billions of distant stars packed together in the disk of our galaxy. For thousands of years, humans wondered what this glowing band could be. Ancient civilizations imagined it as a celestial river, spilled milk of the gods, or a path of spirits across the heavens. It was not until the early 17th century that the Italian astronomer Galileo Galilei pointed one of the first telescopes toward the Milky Way and discovered something extraordinary. The hazy light was not a cloud or mist at all, but countless tiny stars too distant for the human eye to distinguish individually. As telescopes improved over the centuries, astronomers slowly began to understand that the Milky Way was not just a cluster of nearby stars, but a vast galaxy containing our entire stellar neighborhood. And even more astonishingly, they eventually realized that the Milky Way itself was only one galaxy among billions of galaxies scattered throughout the observable universe. Yet despite the unimaginable scale of the universe, the Milky Way remains our immediate cosmic home, the environment in which our sun formed, the gravitational structure that holds our solar system in its slow orbit, and the galaxy whose ancient history is written in the motion of stars and the faint glow of distant nebulae. Every atom in our bodies was once part of this galaxy long before Earth even existed, forged inside ancient stars that lived and died billions of years ago, spreading their material across space where it eventually gathered again to form new stars, new planets, and eventually life itself. Tonight, as you slowly relax and imagine the vast, quiet structure of the Milky Way surrounding us, it becomes easier to picture our place in the cosmos, not as the center of everything, but as a small, peaceful corner within an enormous and ancient galaxy, drifting silently through space, turning slowly around a distant center that has been guiding the motion of billions of stars for longer than our planet has existed. If we could slowly rise far above the Milky Way and look down at it from a distant point in space, the galaxy would reveal a graceful and enormous structure. Not a random cloud of stars, but an organized cosmic pattern shaped over billions of years by gravity and motion. The Milky Way belongs to a family of galaxies known as spiral galaxies, fast-rotating systems where stars and cosmic material arrange themselves into long, sweeping arms that gently curve around a bright central region. From above, the Milky Way would resemble a giant, spinning whirlpool of light, its spiral arms stretching outward like the arms of a great cosmic pinwheel, each arm made of stars, clouds of gas, drifting dust, and glowing nebulae, where new stars are constantly being born. These spiral arms are not solid structures, but regions where stars are slightly more concentrated, slowly moving through waves of density that travel around the galaxy over immense stretches of time. The entire galaxy forms a flattened disk that is incredibly wide compared to its thickness. The Milky Way is estimated to be around 100,000 light-years across from edge to edge, yet its main disk is only about 1,000 light-years thick in many regions, making it somewhat like a gigantic cosmic pancake, made of stars and gas slowly turning through the darkness of intergalactic space. At the very center of this disk lies the galactic bulge, a bright and densely packed region filled with older stars that orbit very close together. Here, the density of stars is far greater than in the calm outer regions where our solar system resides. In the galactic center, stars can be separated by distances far smaller than those found near our sun, and the environment is filled with intense radiation, energetic events, and powerful gravitational forces. Surrounding the central bulge, the spiral arms extend outward in wide, sweeping curves. Astronomers have identified several major arms in the Milky Way, including the Perseus arm, the Sagittarius arm, the Scutum Centaurus arm, and smaller structures that branch between them. These arms are not rigid structures, but slowly shifting regions where stars and gas move in complex patterns while the entire galaxy rotates around its center. Our solar system lies in a smaller structure called the Orion Arm, sometimes referred to as the Orion Spur, which is a modest branch located between two of the larger spiral arms. This location places us in a relatively quiet neighborhood of the galaxy, where stars are spread out more gently and catastrophic cosmic events are less common. If one could travel outward from the center of the galaxy toward its outer edges, the density of stars would slowly decrease. The brilliant, crowded regions near the center would gradually give way to more open areas where stars are separated by greater distances and vast dark clouds of gas drift slowly through space. Beyond the main disk of the galaxy, another mysterious region begins to appear. This is known as the galactic halo, a vast spherical region that surrounds the disk and extends far beyond it into space. Within the halo, there are ancient stars, globular clusters containing hundreds of thousands of stars tightly bound together, and an enormous amount of invisible matter that astronomers believe makes up much of the galaxy's total mass. This invisible material is often referred to as dark matter, and although it cannot be seen directly, it reveals itself through gravity, influencing how stars move within the galaxy and helping hold the entire structure together. Without this unseen mass, the stars in the outer regions of the Milky Way would not remain gravitationally bound in the way we observe today. When we observe distant galaxies through powerful telescopes, many of them appear clearly as beautiful spiral structures similar to the Milky Way, some with tightly wound arms, others with looser sweeping patterns. These galaxies offer astronomers an external view that helps them understand the shape of our own galaxy, even though we are inside it and cannot easily see its full structure. From our position within the galactic disk, we see the Milky Way as a glowing band stretching across the night sky, because we are looking through the dense plane of stars that make up the disk, billions of distant suns blending together into a faint river of light that slowly arches from horizon to horizon on clear, dark nights. The spiral structure of the Milky Way is not fixed in place but constantly evolving. Stars orbit the center of the galaxy at different speeds depending on their distance. Gas clouds collide and collapse to form new stars, and over millions of years, the arms themselves slowly shift and change shape as waves of density move through the galactic disk. If we could watch the galaxy from a distant vantage point over hundreds of millions of years, we would see the Milky Way gently rotating, its spiral arms slowly flowing like streams of starlight around the bright central bulge, a vast cosmic system quietly turning in the darkness while billions of stars continue their long journeys through the galaxy. And somewhere within one small spiral arm of this immense rotating structure, a single ordinary star carries a small collection of planets around it, drifting peacefully through the galactic disk as the Milky Way continues its slow, silent motion through space. When people first hear that our galaxy is enormous, it can be difficult to truly understand what that means. The numbers involved are so large that they move far beyond the scales we experience in everyday life, yet slowly imagining these distances can bring a quiet sense of perspective, a gentle awareness of just how vast the cosmic structure around us truly is. The Milky Way galaxy stretches across a distance of roughly 100,000 light-years from one side of its disk to the other. A light-year itself is already an immense distance. It represents the distance that light travels in one full year, moving at the fastest speed known in the universe. Light moves at nearly 300,000 kilometers every second, fast enough to circle the Earth more than 7 times in a single second. Even at that incredible speed, light needs more than 8 minutes just to travel from the Sun to Earth. Yet to cross the entire Milky Way galaxy, that same beam of light would need about 100,000 years. Meaning that when we look across the galaxy, we are seeing regions whose light began its journey toward us long before human civilization even existed. Inside this enormous structure live an extraordinary number of stars. Astronomers estimate that the Milky Way contains somewhere between 100 billion and 400 billion stars. The exact number is difficult to determine because many stars remain hidden behind thick clouds of interstellar dust that block visible light. To imagine this number, consider that if every star in the Milky Way were represented by a single grain of sand, the total pile would be large enough to fill entire beaches, stretching across coastlines that would seem endless to the human eye. Yet even this comparison still struggles to fully capture the true scale of the galaxy. Among these hundreds of billions of stars, there are also countless planets. In recent decades, astronomers have discovered that planets appear to be extremely common throughout the galaxy. Many stars are surrounded by their own planetary systems. some containing rocky worlds similar in size to Earth, while others contain enormous gas giants larger than Jupiter. It is now believed that the Milky Way may contain hundreds of billions of planets, possibly even more planets than stars, quietly orbiting their suns in distant regions of the galaxy, many of them never receiving the light of any nearby civilization, simply drifting through the silent darkness of space. The vast majority of space within the galaxy, however, is not filled with stars, but with emptiness. The distances between stars are so large that if our sun were reduced to the size of a small coin, the nearest star would still be several hundred kilometers away, scattered across a dark landscape of mostly empty space. Between the stars there exists a thin mixture of gas and microscopic dust particles known as the interstellar medium. This material may seem incredibly sparse compared to anything on Earth, yet across the enormous volume of the galaxy, it adds up to vast clouds, capable of forming entirely new generations of stars. Some of these clouds stretch for hundreds of light years, slowly drifting through the spiral arms of the galaxy, occasionally collapsing under their own gravity to form new stars and planetary systems. A quiet cycle of cosmic renewal that has been taking place for billions of years. Beyond the visible disk of the Milky Way lies an even larger region known as the galactic halo. This halo extends far above and below the disk, forming a vast spherical region surrounding the galaxy. Within it are ancient clusters of stars that may have formed during the earliest stages of the galaxy's history. Even farther outward, there is evidence that an enormous invisible halo of dark matter surrounds the Milky Way. This mysterious substance cannot be seen directly, yet its gravitational influence appears to shape the motion of stars and galaxies across the universe. When astronomers measure the total mass of the Milky Way, including both visible matter and dark matter, the galaxy becomes even more impressive. The Milky Way may contain a mass equal to more than 1 trillion suns, a truly immense gravitational structure holding together billions of stars in a slow rotating system that has existed for nearly 13 billion years. And yet, despite these immense numbers, the galaxy still contains vast quiet regions where stars are separated by enormous distances. Lonely places where a single star may shine in relative isolation for light years in every direction. Our own sun resides in one of these calmer neighborhoods, located about 26,000 light years away from the galactic center, far from the dense, crowded regions where stars gather more tightly together. From this quiet location within the spiral disk, the sun continues its slow journey around the center of the Milky Way, carrying Earth and the rest of the solar system along with it as we move gently through the galaxy. When we look up into the night sky, we are seeing only a tiny portion of this enormous structure, just a few thousand nearby stars visible to the naked eye, while beyond them lie billions more that stretch across the vast disk of our galaxy. And as the Milky Way continues its slow rotation through the darkness of space, our small solar system remains a quiet traveler within it, drifting through a galaxy whose true scale is almost impossible to fully comprehend, yet whose silent presence surrounds us every night above the sleeping world. Within the immense structure of the Milky Way galaxy, our solar system occupies a surprisingly calm and quiet location, far from the crowded center of the galaxy, and also far from the thin outer edge where stars become scarce. It rests in a region that could almost be described as a peaceful suburban neighborhood of the galaxy, surrounded by distant stars that glow quietly across the dark interstellar space. If we could view the Milky Way from far above and slowly zoom inward toward the spiral arms, we would eventually find a small branch structure located between two larger spiral arms. This region is known as the Orion Arm, or sometimes the Orion Spur, a modest ribbon of stars, gas, and dust stretching thousands of light years across the galaxy. Our sun lies within this Orion Arm, positioned about 26,000 light years away from the galactic center, a distance that places our solar system roughly halfway between the center of the galaxy and its outer edge. a location that turns out to be remarkably stable and relatively safe compared to many other regions within the Milky Way. Closer to the galactic center, the density of stars increases dramatically. Stars orbit much closer together and powerful gravitational interactions become far more common. Supernova explosions occur more frequently, and enormous clouds of radiation fill the surrounding space. These environments can be beautiful and energetic, but they are also far more chaotic. In contrast, the region surrounding our solar system is more spread out. The nearest star beyond our Sun is about 4 light-years away, which in galactic terms is considered a comfortable distance between neighbors. Stars here travel along their orbits through the galaxy without constant close encounters with other stars. This peaceful location may have played an important role in the development of life on Earth. If our solar system had formed much closer to the galactic center, powerful radiation events and gravitational disturbances might have made planetary stability far more difficult over long periods of time. At the same time, if we were located much farther out toward the edges of the galaxy, there might not have been enough heavy elements present when the Sun formed. The early outer regions of galaxies tend to contain fewer elements heavier than hydrogen and helium. Yet those heavier elements are essential for building rocky planets and the chemistry required for life. Because of this balance, our location within the Milky Way is sometimes described as part of a region called the galactic habitable zone, a broad area of the galaxy where conditions may be more favorable for the long-term stability of planetary systems. The Sun itself orbits around the center of the Milky Way along with all the other stars in the galaxy, traveling at a speed of roughly 800,000 kilometers per hour. Yet even moving this quickly, the orbit is incredibly long. One full journey around the galactic center takes about 230 million years. Astronomers sometimes call this period a galactic year, which means that since the Sun formed about 4.5 billion years ago, it has completed only around 20 full orbits around the center of the Milky Way. During each of these long galactic journeys, our solar system has slowly drifted through different regions of the spiral arms, passing through clouds of gas and dust, moving between clusters of stars, and occasionally encountering waves of denser material that ripple through the spiral arms of the galaxy. Despite these slow changes, the solar system remains gravitationally bound to the Milky Way, held in its orbit by the immense mass of the galaxy and the gravitational influence of billions of stars, along with the invisible presence of dark matter. From Earth, the location of our solar system inside the galactic disk creates the beautiful glowing band that we see across the night sky. Because when we look along the plane of the galaxy, we are looking through an enormous concentration of distant stars spread across tens of thousands of light years. When we look in directions above or below this plane, the number of visible stars becomes much smaller because we are looking out of the disk into the more empty regions of the galactic halo. The quiet neighborhood where our Sun resides contains many other stars of similar age and composition, some surrounded by their own planetary systems, many of them still being discovered by astronomers using powerful telescopes and sensitive instruments capable of detecting planets orbiting distant stars. These neighboring stars drift slowly through the galaxy along with us, each following its own orbit around the galactic center, while the entire Milky Way continues its gentle rotation through the vast darkness of space. And within this immense rotating galaxy, our small solar system quietly travels along its long galactic path, carrying Earth and the fragile layer of life on its surface through a calm corner of the Milky Way where the stars shine softly across the deep cosmic night. As the Milky Way slowly turns through space, its most recognizable structure is formed by the long sweeping spiral arms that stretch outward from the bright central region of the Milky galaxy. These arms are not solid structures like the arms of a wheel, but rather vast regions where stars, gas, and cosmic dust gather in slightly greater numbers, creating glowing rivers of all starlight that curve through the galactic disk. From a distant viewpoint, The galaxy would appear as a graceful spiral pattern rotating slowly over hundreds of millions of years. The spiral arms winding outward like enormous waves of stars that circle the galactic center again and again, while the entire galaxy continues its quiet motion through intergalactic space. Astronomers studying the structure of the Milky Way have identified several major spiral arms that shape the galaxy's overall appearance. Among the largest of these are the Perseus arm, the Sagittarius arm, and the Scutum Centaurus arm, each one stretching tens of thousands of light years across the galaxy and containing countless star-forming regions and massive clouds of interstellar gas. These arms are not permanent structures made of the same stars forever remaining together. Instead, they are better understood as regions where stars temporarily gather as they move through waves of density that travel slowly around the galaxy, somewhat like traffic slowing down on a busy highway where cars briefly bunch together before spreading out again further down the road. As clouds of gas drift into these denser regions, gravity begins to pull the material inward, causing parts of the cloud to collapse and form new stars. This means that spiral arms are often filled with bright young stars that shine with intense blue and white light, illuminating the surrounding gas clouds and creating some of the most beautiful structures in the galaxy. Because new stars are born frequently within these spiral arms, they often contain glowing nebulae, vast clouds of gas that shine as they are heated by the radiation of newly formed stars. These glowing regions can stretch across dozens or even hundreds of light years, creating luminous patches of color within the dark background of space. Between the major spiral arms, there are also smaller branches and spurs where stars and gas gather in thinner ribbons that extend outward from the larger arms. Our solar system lies within one of these smaller structures known as the Orion Arm, a modest branch located between the larger Sagittarius Arm and the Perseus Arm. The Orion Arm is not as massive as the major spiral arms, but it still contains thousands of stars along with large clouds of gas and dust that continue to form new stars over time. Within this region lie familiar astronomical objects, such as the Orion Nebula, one of the nearest and most active star-forming regions visible from Earth. From our position inside the galaxy, it is very difficult to see the spiral arms directly because dense clouds of cosmic dust block much of the visible light traveling through the galactic disk. For this reason, astronomers must use radio waves, infrared observations, and measurements of star motion to slowly map the structure of the galaxy. By studying these observations, scientists have been able to trace the general shape of the Milky Way's spiral arms and understand how they extend outward from the galactic center, forming a complex and dynamic pattern that continues to evolve over time. Stars within the spiral arms do not remain locked in place within those arms forever. Instead, they orbit the center of the galaxy, moving slightly faster or slower than the density waves that form the spiral structure. Over millions of years, stars drift in and out of the spiral arms while continuing their long journeys around the galaxy. This means that our solar system has likely passed through several spiral arms during its long history, orbiting the Milky Way, each passage lasting millions of years as the sun slowly travels through regions where star formation is more active and interstellar clouds are more common. The spiral arms themselves slowly shift and reshape over extremely long periods of time as gravity, gas movement, and stellar activity influence the structure of the galactic disk. Yet despite these gradual changes, the overall spiral pattern of the Milky Way has likely existed for billions of years. When we look at distant galaxies through powerful telescopes, many of them display spiral structures, similar to our own galaxy, some with tightly wound arms and others with wide open curves of starlight. These distant galaxies offer a glimpse of what the Milky Way might look like if we could step outside it and observe its full shape from afar. From our quiet position within the Orion Arm, we continue our slow orbit around the galactic center, surrounded by distant stars that drift along the spiral structure of the Milky Way. Way while the entire galaxy gently rotates through the deep darkness of space, forming one of the great cosmic patterns of the universe. Deep within the heart of the Milky Way galaxy, there exists a region unlike any other place in our cosmic neighborhood. A crowded and energetic environment where stars gather in extraordinary numbers and gravity shapes the motion of everything around it. This is the galactic center, the true gravitational heart of the galaxy around which billions of stars slowly orbit. While our solar system drifts peacefully in a quiet spiral arm more than 26,000 light-years away, the center of the galaxy is a very different place. The density of stars increases dramatically as one approaches the core. Regions that may contain millions of stars packed within distances far smaller than those separating the stars near our sun. If we could travel toward the galactic center, the night sky would slowly grow brighter as more and more stars filled the sky in every direction. Instead of a few thousand visible stars, there could be millions shining across the sky, forming a brilliant dome of starlight that would never fade into darkness. This central region of the galaxy is known as the galactic bulge, a thick rounded structure of stars that rises above and below the flat disk of the Milky Way, containing many of the oldest stars in the galaxy. Stars that formed billions of years ago, during the early stages of the Milky Way's formation. These stars move through the bulge in complex orbits influenced by the enormous gravitational forces near the galactic center. Unlike the relatively orderly circular orbits found in the spiral arms, the stars within the bulge follow more varied paths moving in different directions around the core of the galaxy. Hidden deep within this dense region lies one of the most mysterious objects in the Milky Way, a supermassive black hole known as Sagittarius, a star. An invisible point in space where gravity becomes so strong that nothing, not even light, can escape once it crosses the boundary, known as the event horizon. Although the black hole itself cannot be seen directly, astronomers have discovered its presence by carefully observing the motion of stars orbiting extremely close to the galactic center. These stars move at astonishing speeds, following tight elliptical paths that reveal the presence of an incredibly massive object at the center. The mass of this central black hole is estimated to be more than 4 million times greater than the mass of our sun. Yet, despite its immense gravitational power, it occupies a region of space far smaller than the distances separating most stars in the galaxy. Surrounding the central black hole is a region filled with hot gas, powerful magnetic fields, and intense radiation. Occasionally, clouds of gas drift too close to the black hole and begin spiraling inward, heating up dramatically as they fall toward the event horizon, releasing bursts of energy before disappearing from view. Even though the galactic center is such an energetic environment, its enormous distance from Earth means that its activity has very little direct effect on our solar system. The sun and its planets continue their quiet orbit through the outer regions of the galaxy, far from the extreme conditions near the core. Observing the galactic center is also challenging because thick clouds of interstellar dust lie between Earth and the center of the galaxy, blocking much of the visible light that would otherwise reach our telescopes. For this reason, astronomers often study the region using infrared light radio waves and other forms of radiation that can pass through the dust. Through these observations, scientists have slowly built a clearer picture of the complex environment surrounding the center of the Milky Way, revealing clusters of massive stars, turbulent clouds of gas, and the powerful gravitational influence of the supermassive black hole that anchors the galaxy. The entire Milky Way galaxy rotates around this central region. Stars in the spiral arms, stars in the halo, and even the distant globular clusters all follow orbits shaped by the combined gravitational pull of the galaxy's mass, concentrated toward the center. Our sun is one of those countless travelers moving slowly around the galactic core, completing one orbit every 230 million years. A journey so long that life on Earth changes dramatically between each galactic year. And while the quiet stars of our region shine gently across the night sky, the distant galactic center continues its silent activity far away in the depths of the Milky Way, a hidden and powerful heart guiding the slow rotation of our entire galaxy as it drifts through the immense darkness of space. At the very center of the Milky Way galaxy, hidden behind dense clouds of cosmic dust, lies one of the most extraordinary objects in our galactic home, an invisible gravitational giant known as Sagittarius, a star. A supermassive black hole that quietly sits at the heart of the galaxy, shaping the motion of stars across vast distances. For a long time, astronomers suspected that something extremely massive existed at the center of the Milky Way, but it was impossible to see directly. The thick clouds of interstellar dust between Earth and the galactic center block most visible light, making the region appear dark and mysterious when observed with ordinary telescopes. However, by using infrared telescopes and radio observations, scientists were able to peer through the dust and carefully watch the motion of stars orbiting very close to the galactic center. Over many years, these stars were observed tracing tight, curved paths through space, moving at incredibly high speeds. Some of these stars travel thousands of kilometers per second as they swing around the invisible object at the center, completing entire orbits in just a few decades. Movements that can only be explained by the presence of an extremely massive object concentrated in a very small region of space. By measuring these motions, astronomers determined that the object at the center must contain more than 4 million times the mass of our Sun packed into an area smaller than the orbit of Mercury around the Sun. The only known phenomenon capable of containing such enormous mass within such a small volume is a black hole. A black hole forms when gravity becomes so powerful that it pulls matter into an incredibly dense point, causing space itself to curve inward. Around this region lies a boundary called the event horizon. Once anything crosses this boundary, it can no longer escape the pull of the black hole. Even light cannot escape from within the event horizon, which is why black holes appear completely dark against the surrounding space. Yet the area around them can become extremely bright when gas dust or even entire stars drift too close and begin falling inward. As matter spirals toward the black hole, it forms a swirling disk of hot material known as an accretion disk. Friction within this disk heats the gas to enormous temperatures, causing it to glow with intense energy before the material eventually disappears beyond the event horizon. In the Milky Way, the central black hole is relatively calm compared to the black holes found in some distant galaxies, where enormous jets of energy shoot outward across intergalactic space. Sagittarius, a star, occasionally consumes small clouds of gas, but most of the time it remains surprisingly quiet. Despite this calm behavior, its gravitational influence extends across the entire central region of the galaxy, helping anchor the motion of stars in the galactic core and contributing to the overall structure of the Milky Way. The discovery of the Milky Way's central black hole was confirmed through decades of careful observation, including precise measurements of individual stars orbiting the galactic center. Some of these stars have been tracked for more than 20 years, revealing complete orbits around the unseen object. One of the most famous of these stars, known as S2, moves along an elongated orbit, bringing it extremely close to the black hole before swinging back outward again. During its closest approach, the star travels at tremendous speeds, demonstrating the immense gravitational pull present at the center. Although the black hole is powerful, it does not act like a cosmic vacuum pulling everything in from across the galaxy. Objects must come very close before the gravitational pull becomes strong enough to capture them. Stars located thousands of light years away, including our Sun, continue their stable orbits without any danger of falling toward the center. Our solar system lies far from this extreme environment, about 26,000 light years away, in a quiet spiral arm where the influence of the central black hole is simply part of the larger gravitational balance of the galaxy. From Earth, the region surrounding the galactic center appears as a dense and glowing patch of the Milky Way band in the direction of the constellation Sagittarius. Yet the true drama of this region remains hidden behind thick curtains of dust and gas that block our direct view. Even so, modern telescopes and careful measurements have allowed astronomers to build a detailed understanding of this mysterious region, revealing that deep within the center of our galaxy lies a massive black hole quietly shaping the motion of stars in its surrounding region. And while this invisible giant sits at the heart of the Milky Way, our solar system continues its calm journey through the outer spiral arms, orbiting the same distant center while the galaxy slowly rotates through the vast silent darkness of space. Throughout the vast expanse of the Milky Way galaxy, hundreds of billions of stars shine quietly across the cosmic darkness. Yet these stars are not all the same. They vary in size, temperature, brightness, color, and lifespan, forming a diverse population of stellar objects that together shape the structure and evolution of the galaxy. When we look at the night sky from Earth, most stars appear similar to the naked eye, small steady points of light scattered across the darkness. But in reality, stars come in many different forms, ranging from small, faint red stars that burn slowly for trillions of years to enormous blue giants that live fast, brilliant lives before ending in powerful cosmic explosions. The most common stars in the Milky Way are small red stars known as red dwarfs. These stars are far smaller and cooler than our sun, and they emit a gentle reddish light that is often too faint to see from great distances. Despite their quiet appearance, red dwarfs are extremely long-lived because they burn their fuel very slowly, allowing them to shine for periods far longer than the current age of the universe. Astronomers believe that red dwarfs make up the majority of stars in the Milky Way galaxy, meaning that most stellar systems in our galaxy orbit these small, stable suns rather than stars like our own. Our sun belongs to a class known as yellow dwarf stars, although in reality it appears more white than yellow when viewed from space. It is a medium-sized star, neither particularly large nor particularly small, compared with the enormous variety of stars that exist throughout the galaxy. Stars like the sun shine by fusing hydrogen into helium deep within their cores, releasing enormous amounts of energy that radiate outward through space as light and heat. This steady nuclear process allows stars like the sun to remain stable for billions of years, providing consistent energy to any planets that may orbit around them. Larger stars also exist within the Milky Way, some of which are many times more massive than the sun. These massive stars burn their fuel much faster, producing intense blue or white light and living far shorter lives, often lasting only a few million years before exhausting their nuclear fuel. These giant stars can grow to sizes so large that if one replaced the sun in our solar system, its outer layers might extend beyond the orbit of Mars or even Jupiter, filling a huge region of space with brilliant light and powerful stellar winds. When massive stars reach the end of their lives, they often explode in spectacular events known as supernovae, releasing enormous bursts of energy that briefly outshine entire galaxies and scattering heavy elements across space. These elements become the building blocks for new stars' planets, and eventually the atoms that make up living things, meaning that every element heavier than hydrogen in our bodies was once created inside the heart of a star somewhere within the galaxy. There are also aging stars known as red giant stars that were once similar to the sun, but have expanded dramatically as they near the final stages of their lives. During this phase, the outer layers of the star swell outward, becoming cooler and redder, while the inner core continues to evolve. Eventually, some stars shed their outer layers entirely, creating beautiful glowing shells of gas known as planetary nebulae, leaving behind dense stellar remnants, such as white dwarfs, small, incredibly compact stars that slowly cool over billions of years. In the case of extremely massive stars, their final collapse can produce neutron stars, objects so dense that a single teaspoon of their material would weigh billions of tons on Earth. Some neutron stars rotate incredibly fast, emitting beams of radiation that sweep across space like cosmic lighthouses. These objects are known as pulsars, and they can spin hundreds of times each second. Across the Milky Way, all of these different types of stars coexist, forming a constantly evolving population, where new stars are born within clouds of gas while older stars gradually reach the ends of their long lives. The galaxy therefore becomes a vast cycle of stellar birth, evolution, and transformation, with each generation of stars contributing new material to the next generation through explosions, stellar winds, and drifting clouds of gas. Our sun itself is thought to be about 4.5 billion years old, placing it roughly in the middle of its stable lifetime, meaning it will likely continue shining for another 5 billion years before eventually expanding into a red giant and entering its own final stages of stellar evolution. Until that distant time, the sun will remain one quiet star among hundreds of billions in the Milky Way galaxy, drifting along its slow orbit through the spiral arms surrounded by countless other stars, each following its own long and silent journey through the cosmic night. Across the Milky Way galaxy, new stars are quietly being born all the time, hidden within enormous drifting clouds of gas and dust that slowly move through the spiral arms of the galaxy. These vast cosmic nurseries are some of the most beautiful and mysterious regions in the entire galaxy, where gravity slowly gathers scattered material together until a new star begins its long life. Between the stars, there exists a thin mixture of hydrogen gas, helium, and tiny dust particles that together form what astronomers call the interstellar medium. Most of this material is extremely sparse, yet in certain regions it gathers into massive clouds that can stretch across dozens or even hundreds of light years. These giant clouds are often called molecular clouds because they contain molecules of hydrogen and other simple compounds. Inside them, temperatures are very cold, and the gas drifts slowly through space, forming dense dark structures that can appear like shadowy patches against the bright background of the whole, the Milky Way. Within these clouds, gravity quietly begins its work. Small fluctuations in density cause certain regions of the cloud to gather more material than others, and slowly, these denser pockets begin collapsing inward under their own weight. As the gas falls inward, it begins to heat up and spin, forming a rotating ball of hot material known as a protostar. At this stage, the young star is still surrounded by the remaining cloud of gas and dust that helped create it. Over time, the pressure and temperature in the center of the protostar continue rising until eventually nuclear fusion begins. Hydrogen atoms start fusing together to form helium, releasing enormous amounts of energy, and the new star finally ignites. This moment marks the true birth of a star, a new point of light shining into the galaxy where once there was only a cold, drifting cloud of gas. The remaining gas and dust around the newborn star often forms a rotating disk of material, and within this disk, small grains of dust begin sticking together, forming larger and larger bodies over millions of years. This slow process can eventually lead to the formation of planets, moons, asteroids, and comets. Our own solar system likely formed in exactly this way about 4.5 billion years ago, inside a large molecular cloud somewhere within the Milky Way. Gravity pulled material together, forming the young sun, while the remaining disk slowly gathered into the planets we know today. Some star-forming regions produce only a few stars, while others create entire clusters of hundreds or even thousands of stars that form together from the same cloud of gas. One of the most famous star-forming regions visible from Earth is the Orion Nebula, located about 1,300 light-years away. Within this glowing cloud of gas, astronomers have observed many young stars still surrounded by disks of material, where future planetary systems may one day emerge. Inside these stellar nurseries, bright young stars illuminate the surrounding gas, creating glowing regions of color, as ultraviolet light excites the hydrogen gas, causing it to shine softly across the dark background of space. Yet star formation does not continue forever in a single region. Powerful winds and radiation from newly formed stars eventually begin pushing away the remaining gas, dispersing the cloud, and ending the star formation process. Over time, the newborn stars drift apart slowly, moving through the galaxy, each following its own orbit around the galactic center, while the cloud that once gave birth to them fades away into the interstellar medium. Across the Milky Way, this quiet cycle continues endlessly. Giant clouds slowly collapse, forming new stars, while older stars reach the ends of their lives, returning material back into space where it can become part of future generations of stars and planets. This constant recycling of matter means that the atoms within our own bodies once belonged to earlier stars that lived long before the sun was born. The calcium in our bones, the oxygen we breathe, and the iron in our blood were all forged inside ancient stars somewhere in the galaxy. When those stars ended their lives, they released their material into the surrounding space where it eventually became part of the cloud that formed our solar system. And so, within the silent darkness of the Milky Way, enormous clouds of gas continue drifting slowly through the spiral arms, waiting for gravity to gather them together once again, beginning the quiet process that will eventually light new stars across the galaxy. Throughout the Milky Way galaxy, there exist enormous drifting clouds of gas and dust that glow softly across the darkness of space. These beautiful and mysterious structures are known as nebulas, vast cosmic formations that can stretch across many light years and serve as some of the most important environments within the galaxy. The word nebula originally comes from a Latin word meaning cloud, and when astronomers first observed these objects through early telescopes, they appeared exactly like faint cloudy patches in the sky, gentle glowing regions whose true nature was not yet fully understood. Today we know that nebulas are enormous collections of gas and microscopic dust particles floating between the stars of the galaxy. Most of this material is made of hydrogen, the simplest and most abundant element in the universe, along with smaller amounts of helium, oxygen, carbon, and other elements created inside earlier generations of stars. Some nebulas are the birthplaces of new stars, while others are the remains of stars that have reached the end of their lives. Each type of nebula tells a different story about the life cycle of matter within the Milky Way. One of the most common types of nebula is the emission nebula. These clouds glow with soft colors because the gas within them is energized by radiation from nearby young stars. When ultraviolet light from these hot stars strikes the surrounding hydrogen gas, it causes the gas to shine with a faint reddish light that can extend across huge regions of space. These glowing emission nebulas often mark areas where star formation is actively taking place. Deep within the clouds, gravity slowly pulls gas together, forming new stars, while the surrounding material continues glowing under the influence of nearby stellar radiation. Another type of nebula is the reflection nebula. Instead of glowing from its own energy, this type of cloud simply reflects the light of nearby stars. Tiny dust particles scatter the starlight, giving the nebula a soft bluish appearance that seems almost like a faint cosmic mist drifting through the galaxy. There are also dark nebulas, which appear as deep shadowy regions against the bright background of the Milky Way. These clouds are so dense with dust that they block the light from stars behind them, creating dark shapes within the glowing band of the galaxy. Although they appear empty and dark, these regions often contain enormous amounts of gas and dust, and may be the early stages of future star-forming regions where gravity will eventually begin the slow process of creating new stars. Perhaps the most dramatic type of nebula forms when a star reaches the final stages of its life and releases its outer layers into space. These structures are known as planetary nebulas, even though they have nothing to do with planets. When a star similar to our Sun begins to exhaust its nuclear fuel, its outer layers expand outward and are gradually pushed away into space, forming a glowing shell of gas surrounding the small dense core that remains behind. These expanding shells of gas can form intricate patterns of color and shape, creating some of the most beautiful objects ever observed in the night sky. Delicate rings, glowing bubbles, and complex symmetrical patterns that slowly expand across space over thousands of years. Eventually, the glowing gas disperses into the interstellar medium, becoming part of the material that will one day contribute to the formation of new stars and planets. Nebulas therefore represent both beginnings and endings within the Milky Way. Some are places where stars are just beginning their long lives, while others mark the quiet fading moments of stars that have already lived for billions of years. Across the spiral arms of the galaxy, thousands of nebulas drift slowly through space, each one participating in the great cycle of matter that shapes the evolution of the Milky Way. When we observe these vast clouds through powerful telescopes, we are seeing enormous regions of cosmic activity where gravity, radiation, and time slowly transform simple clouds of gas into the brilliant stars that fill the galaxy. And somewhere long ago, within a nebula, much like these, our own sun was born surrounded by a swirling cloud of gas and dust that eventually formed the planets, including the small blue world where we now quietly look up into the night sky and observe the glowing nebulas scattered across our galactic home. Across the Milky Way, galaxy stars are not always spread evenly through space. In many regions, they gather together in groups bound by gravity, forming structures known as star clusters. These clusters are among the oldest and most fascinating communities of stars in the galaxy, and they provide astronomers with valuable clues about how stars form, evolve, and move through the Milky Way over immense stretches of time. When stars are born inside large molecular clouds, they often form together in groups rather than alone. The collapsing cloud fragments into many smaller regions, each giving birth to a new star, and as these stars ignite, they remain gravitationally connected to one another, forming a cluster that drifts slowly through the galaxy. There are two main types of star clusters found within the Milky Way: open clusters and globular clusters. Each one very different in size, structure, and age, yet both representing important pieces of the galaxy's history. Open clusters are relatively young groups of stars that formed from the same cloud of gas and dust. They typically contain anywhere from a few dozen to several thousand stars, loosely bound together by gravity. These clusters are often found within the spiral arms of the galaxy, where star formation continues to take place. Because the stars in an open cluster formed at roughly the same time, they share similar ages and chemical compositions. Studying these clusters allows astronomers to better understand how stars evolve, since all the stars in the group can be compared as they gradually age together. Over millions of years, however, the gravitational pull of the galaxy slowly begins to pull these clusters apart. Interactions with nearby stars, passing clouds of gas, and the tidal forces of the Milky Way gradually scatter the stars until the cluster eventually dissolves and its members drift separately through the galaxy. One famous example of an open cluster visible from Earth is the Pleiades cluster, also known as the Seven Sisters. Located about 400 light-years away, this cluster appears as a small grouping of bright blue stars that can often be seen with the naked eye in dark skies. These stars formed relatively recently in cosmic terms, only about 100 million years ago, and they still travel through the galaxy together as a loose family of stars that were born from the same ancient cloud. In contrast to open clusters, the Milky Way also contains much older and more densely packed structures known as globular clusters. These are massive spherical collections of stars that orbit the galaxy and the distant halo surrounding the galactic disk. Globular clusters can contain hundreds of thousands or even millions of stars packed into a relatively small region of space, forming brilliant spherical swarms of starlight that glow softly when observed through telescopes. Unlike open clusters, the stars in globular clusters are extremely old. Many of them formed more than 10 billion years ago during the early stages of the Milky Way's formation, making them some of the oldest surviving structures in the galaxy. Because these clusters formed so early in the history of the galaxy, their stars contain fewer heavy elements compared to younger stars like our Sun. Studying them allows astronomers to learn about the conditions that existed when the Milky Way was still forming. More than 150 globular clusters have been discovered orbiting the Milky Way, and they move through enormous elongated paths far above and below the galactic disk, slowly circling the galaxy over periods that can last hundreds of millions of years. From Earth, these clusters appear as small fuzzy balls of light when viewed through telescopes, but inside them thousands upon thousands of stars shine together, creating one of the most densely populated stellar environments in the galaxy. Within the crowded centers of globular clusters, the distance between neighboring stars can be much smaller than the distances we observe near our sun, creating a sky that would appear filled with brilliant stars in every direction. Despite this density, the stars in these clusters have remained gravitationally bound together for billions of years, continuing their slow orbit around the Milky Way as ancient witnesses to the galaxy's earliest history. Across the Milky Way, both open clusters and globular clusters continue their quiet journeys through space, some slowly dissolving over time, while others remain stable for billions of years. Together, these clusters reveal how stars are born, how they evolve, and how gravity shapes their motion across the galaxy, allowing astronomers to trace the long history of the Milky Way itself. And as our solar system quietly travels through its spiral arm, countless star clusters drift through the galaxy as well, glowing softly across the darkness like distant gatherings of ancient suns slowly orbiting the same galactic center, far beyond our distant sky. Within the vast population of stars scattered across the Milky Way galaxy, many of those stars are not alone. Surrounding them are entire planetary systems, where worlds of many different kinds quietly orbit their suns. Some of these systems resemble our own solar system, while others are completely different, filled with planets unlike anything we have ever seen. For most of human history, people could only wonder whether other stars might have planets of their own. The distances between stars were so enormous that observing such small objects seemed almost impossible. Yet in recent decades, astronomers have developed new techniques and instruments capable of detecting planets orbiting distant stars. These distant worlds are known as exoplanets, meaning planets that exist outside our solar system. And since the first confirmed discoveries in the 1990s, thousands of exoplanets have been identified within the Milky Way galaxy. Many of these discoveries were made using a method known as the transit technique. When a planet passes in front of its star from our point of view, the brightness of the star dims very slightly for a short time. By measuring these tiny changes, astronomers can detect the presence of planets even though the planets themselves cannot be directly seen. Another method involves observing the subtle motion of a star as it is gently pulled back and forth by the gravitational influence of an orbiting planet. This tiny movement can reveal the mass of the unseen planet and the shape of its orbit around the star. Through these observations, scientists have discovered that planetary systems are extremely common throughout the Milky Way. Many stars appear to host multiple planets, and the variety of these worlds is astonishing. Some exoplanets are massive gas giants, larger than Jupiter, orbiting extremely close to their stars where temperatures reach thousands of degrees. These worlds are sometimes called hot Jupiters because of their enormous size and intense heat. Other planets are rocky worlds similar in size to Earth, while some appear to be covered by deep global oceans or thick atmospheres of gas unlike anything found in our own solar system. There are also planets that orbit two stars at once, moving through space under the gravitational pull of twin suns, creating skies that might contain two bright stars rising and setting together. Astronomers have also found planets drifting freely through the galaxy without orbiting any star at all. These wandering worlds may have once belonged to planetary systems, but were later ejected by gravitational interactions, leaving them to travel alone through the darkness of interstellar space. Within the Milky Way, There may be hundreds of billions of planets scattered among the hundreds of billions of stars that fill the galaxy, meaning that planets could be nearly as common as stars themselves. Some of these worlds orbit within what astronomers call the habitable zone around their stars, a region where temperatures might allow liquid water to exist on the surface. Water being one of the key ingredients for life as we understand it. Although no confirmed evidence of life beyond Earth has yet been discovered, the vast number of planetary systems in the Milky Way suggests that environments suitable for life could exist in many different regions of the galaxy. Our own solar system formed about 4.5 billion years ago, when a cloud of gas and dust collapsed under gravity, forming the young sun at its center. The remaining material flattened into a rotating disk where particles slowly gathered together, forming the planets, moons, asteroids, and comets that continue to orbit the sun today. This process of planetary formation appears to be common across the galaxy, meaning that similar disks of gas and dust are likely forming new planets around young stars even now. Within the spiral arms of the Milky Way, each planetary system develops its own unique structure, depending on the mass of its star, the amount of material in the surrounding disk, and the gravitational interactions between, forming planets. Some systems may contain tightly packed groups of rocky planets, while others may be dominated by large gas giants that shape the orbits of smaller worlds around them. Across the immense disk of the Milky Way, countless planetary systems drift slowly through space, orbiting their stars, while those stars themselves travel around the galactic center as part of the great rotation of the galaxy. And somewhere within this vast population of stars and planets, our small solar system quietly continues its journey through the Orion arm of the Milky Way, carrying Earth and the fragile layer of life upon it, through a galaxy filled with countless other worlds, waiting silently in the cosmic night. Between the countless stars that shine across the Milky Way galaxy, there exists a vast and delicate mixture of gas and microscopic dust drifting slowly through the darkness of space. This material may appear thin and almost empty when compared with the dense matter found on planets or inside stars, yet across the enormous scale of the galaxy, it forms immense structures that play a vital role in shaping the life cycle of stars. Astronomers refer to this diffuse material as the interstellar medium, a quiet ocean of particles filling the spaces between stars across the spiral arms of the galaxy. Most of this material is composed of hydrogen, the simplest and most abundant element in the universe, along with smaller amounts of helium and traces of heavier elements created in earlier generations of stars. Although the density of the interstellar medium is extremely low by earthly standards, often containing only a few atoms within each cubic centimeter of space, the enormous volume of the Milky Way means that the total amount of this material is still immense. Within certain regions of the galaxy, gravity and motion cause this gas and dust to gather together, forming large clouds that can stretch across dozens or even hundreds of light years. These clouds drift slowly through the spiral arms, carried along by the rotation of the galaxy. Some of these clouds remain relatively diffuse, forming faint regions of gas that are difficult to detect, while others become much denser, creating the molecular clouds where new stars may eventually form. Inside these dense clouds, temperatures can fall to extremely low levels, allowing hydrogen atoms to combine into molecules, forming what astronomers call molecular hydrogen. These cold, dark regions often appear as shadowy shapes against the glowing background of the Milky Way because the dust inside them blocks the light of distant stars. The dust particles within these clouds are extremely small, often no larger than tiny grains of smoke, yet they play an important role in the chemistry of interstellar space. Surfaces of dust grains allow simple atoms to combine, forming more complex molecules, including water, carbon monoxide, and other compounds that drift through the galaxy. These clouds are not motionless. They slowly move and evolve under the influence of gravity, stellar winds, radiation, and the large-scale rotation of the Milky Way. Sometimes two clouds collide, compressing the gas within them and triggering the collapse that leads to the birth of new stars. Other times, powerful events such as supernova explosions send shock waves through nearby regions of space, pushing gas and dust into new shapes and stirring the interstellar medium into complex patterns. Over millions of years, these processes continuously reshape the distribution of gas and dust across the galaxy, creating new clouds, dispersing old ones, and maintaining the cycle that allows stars to continue forming throughout the Milky Way. Gas and dust clouds also play a major role in shaping how we observe the galaxy from Earth. Many regions of the Milky Way appear dark in visible light because thick concentrations of dust absorb or scatter the light traveling through the galactic disk. For this reason, astronomers often use infrared telescopes, which can detect longer wavelengths of light capable of passing through the dust, revealing hidden stars and structures within the galaxy that would otherwise remain invisible. In some regions, the gas within these clouds becomes illuminated by nearby stars, creating glowing nebulae, where the hydrogen gas shines softly across the darkness of space, forming beautiful shapes that stretch across many light years. In other places, the clouds remain cold and dark, slowly drifting through the spiral arms of the galaxy, waiting for gravity to begin the slow process that may eventually lead to the formation of new stars. These vast drifting clouds therefore represent the raw material from which stars and planetary systems are formed. Without them, the galaxy would slowly run out of the matter needed to create future generations of stars. Our own solar system was once part of such a cloud billions of years ago, before gravity gathered that material together, forming the young sun and the rotating disk of dust that later became the planets. Even today, the Milky Way continues to contain enormous reservoirs of gas and dust, scattered across its spiral arms, quietly moving through space as the galaxy rotates. And within these silent, drifting clouds, the ingredients for future stars and planets remain patiently waiting as gravity slowly shapes the next chapters in the long and gentle story of our galactic home. Far beyond the bright spiral arms and the thin rotating disk of the Milky Way, there exists another vast and mysterious region that surrounds the entire galaxy. A faint spherical structure known as the galactic halo, a quiet and ancient part of the galaxy that extends far above and below the visible disk of stars. When we imagine the Milky Way, we often picture the flat spiral shape with its glowing arms of starlight. Yet this familiar disk is only part of the galaxy's full structure. Surrounding it is a much larger region where stars become far more sparse, and where some of the oldest objects in the galaxy slowly travel through enormous orbits around the galactic center. The galactic halo is difficult to see directly because it contains relatively few bright stars compared to the crowded spiral arms of the galactic disk. However, careful observations have revealed that this faint outer region stretches tens of thousands of light years beyond the main body of the galaxy. Within the halo, astronomers have discovered ancient stars that formed during the earliest stages of the Milky Way's history, more than 10 billion years ago. These stars contain fewer heavy elements than younger stars because they were created before many generations of stellar explosions enriched the galaxy with heavier atoms. Because of this, the halo stars act almost like time capsules, preserving information about what the Milky Way was like when it was still forming during the early universe. Many of the objects found in the halo are globular clusters, massive spherical groups of stars that orbit the galaxy in long elliptical paths. Each cluster may contain hundreds of thousands or even millions of stars tightly bound together by gravity. These globular clusters are among the oldest known structures in the galaxy, and their wide orbits carry them far above and below the galactic disk, sometimes traveling tens of thousands of light years away from the plane where most stars reside. When viewed through telescopes, globular clusters appear as dense glowing spheres of starlight, floating in the darkness of space. Inside them, the stars are packed much closer together and the stars near our sun, creating environments where the night sky would appear filled with brilliant light in every direction. Beyond the visible stars and clusters, the galactic halo also appears to contain a vast amount of invisible matter known as dark matter. Although this mysterious substance cannot be seen directly, its presence is revealed through the way gravity affects the motion of stars within the galaxy. When astronomers measure how quickly stars move in the outer regions of the Milky Way, they find that the visible matter alone cannot account for the observed motion. Something else must be providing additional gravitational pull to keep the galaxy held together. This unseen mass forms an enormous halo, surrounding the galaxy, extending far beyond the visible stars, possibly reaching distances of several 100,000 light-years from the galactic center. The dark matter halo may contain several times more mass than all the stars, gas, and dust within the Milky Way combined, making it one of the most important components shaping the galaxy's overall structure. Although we cannot see dark matter directly, its gravitational influence guides the motion of stars and galaxies across the universe, helping determine how large structures like the Milky Way formed and evolved over billions of years. Within the halo, there are also faint streams of stars that appear to be the remnants of smaller galaxies that were once pulled into the Milky Way long ago. As these smaller systems were gradually torn apart by gravitational forces, their stars spread out, forming long arcs that continue orbiting the galaxy. These stellar streams reveal that the Milky Way has grown over time by absorbing smaller neighboring galaxies, slowly adding their stars to the halo and outer regions of the galaxy. From our location within the spiral disk, the galactic halo is mostly invisible to the naked eye because its stars are scattered across enormous distances. Yet it remains an essential part of the galaxy's full structure, surrounding the bright disk like a vast, silent sphere. As the Milky Way slowly rotates through space, the stars of the halo follow long, sweeping orbits around the galactic center, moving quietly through regions far above the glowing spiral arms. And while our solar system continues its calm journey through the Orion arm deep within the galactic disk, the ancient stars of the halo drift through the outer reaches of the Milky Way, carrying with them the quiet memory of the galaxy's earliest history. The Milky Way galaxy may appear calm and still when we observe the night sky from Earth, yet in reality the entire galaxy is in constant motion, slowly rotating through space as billions of stars travel along enormous paths around the galactic center. Every star within the galaxy, including our sun, is part of this great cosmic movement, each one following its own orbit, shaped by the combined gravitational influence of the galaxy's enormous mass. If we could step far outside the Milky Way and watch it over hundreds of millions of years, we would see the galaxy slowly turning like a vast spiral wheel, its arms gently sweeping around the bright central region, while clouds of gas and stars drift along the rotating disk. The rotation of the Milky Way is not exactly the same everywhere across the galaxy. Stars closer to the galactic center travel along shorter paths and therefore move around the center more quickly, while stars farther out travel along wider orbits and take much longer to complete a full journey. Our solar system is located about 26,000 light-years from the galactic center, and at this distance the sun moves through space at a speed of roughly 800,000 kilometers per hour as it orbits the center of the galaxy. Even at this tremendous speed, the orbit is so large that completing one full revolution around the Milky Way takes about 230 million years. Astronomers sometimes refer to this enormous span of time as a galactic year, which means that during the entire history of humanity, the sun has moved only a tiny fraction of the way along its long orbit around the galaxy. When the sun last passed through this exact region of the Milky Way, roughly 230 million years ago, life on Earth looked very different. Dinosaurs were beginning to dominate the land, and the continents themselves were arranged in a very different pattern. During each galactic year, our solar system slowly drifts through different regions of the spiral arms, occasionally passing through areas where gas clouds are more common or where star formation is more active. These movements happen so gradually that no noticeable change can be observed over human lifetimes. Yet over millions of years, the position of the Sun within the galaxy slowly shifts as it continues its long orbit. Stars within the spiral arms do not all move together like objects fixed to a rotating disk. Instead, each star travels at its own speed depending on its distance from the galactic center and the gravitational forces acting upon it. Because of this, the spiral arms themselves are not permanent structures made of the same stars forever remaining together. Rather, they behave more like waves of higher density, where stars temporarily gather as they move through the galaxy. As stars pass through these denser regions, they may encounter clouds of gas that can collapse to form new stars, helping maintain the bright appearance of the spiral arms across the spiral galaxy. While the stars move around the galactic center, the entire Milky Way also travels through space as part of a much larger cosmic structure. The galaxy is slowly drifting within a group of nearby galaxies bound together by gravity known as the local group. Within this group, the Milky Way and the Andromeda Galaxy are the two largest members, and both are gradually moving toward one another in a slow cosmic approach that will eventually reshape both galaxies billions of years in the future. Yet within the timescales of human history, the motion of the Milky Way remains gentle and almost impossible to notice. The stars we see in the night sky appear fixed in place because their movements across the sky occur extremely slowly. Over thousands of years, careful observers can detect slight changes in the positions of nearby stars, but the full rotation of the galaxy unfolds over periods so long that entire species can rise and fall on Earth, while the Milky Way continues only a small fraction of its turn. Still, every moment our solar system is traveling through the galaxy carried along by the rotation of the Milky Way as the Sun follows its quiet path around the distant galactic center. And while we rest beneath the stars, the entire galaxy continues its slow, silent motion through space, a vast spiral of light gently turning across the darkness of the universe. As the Milky Way slowly rotates through space, our Sun is not standing still within the galaxy. It is constantly moving along a vast path around the galactic center, carrying the entire solar system with it through the quiet regions of the spiral arms. This journey is unimaginably long compared to human timescales. The Sun travels at a speed of roughly 800,000 kilometers per hour as it moves through the galaxy. Yet, the orbit it follows is so enormous that completing one full trip around the center of the Milky Way takes about 230 million years. Astronomers sometimes describe this immense period as a galactic year, and when we think about it this way, the age of the Sun becomes even more interesting. Since the Sun formed about 4.5 billion years ago, it has completed only around 20 full galactic orbits during its entire lifetime. Each of those long journeys carried the solar system through different regions of the Milky Way, where the environment of the galaxy slowly changed around it as stars, clouds of gas, and spiral arms drifted along their own paths. During these immense spans of time, continents on Earth have moved across the surface of the planet, oceans have opened and closed, and countless species of life have appeared and disappeared while the Sun continued its slow journey around the galaxy. The path of the Sun around the galactic center is not perfectly flat or completely circular. Instead, it follows a gentle wave-like motion, slowly rising above and dipping below the thin disk of the Milky Way as it travels through space. This vertical movement takes tens of millions of years and means that over time, our solar system oscillates slightly above and below the main plane of the galaxy. When the Sun passes through the dense regions of the galactic disk, it may encounter more interstellar clouds and regions where star formation is active, while at other times it drifts through quieter areas where stars are more widely spaced. These changes occur so gradually that they unfold across geological timescales rather than human lifetimes. Yet they represent part of the larger rhythm of motion that shapes the structure of the Milky Way. Our solar system also moves relative to the nearby stars surrounding us in the Orion Arm. Although many of these stars appear fixed in the night sky, they are each traveling through the galaxy along their own paths. Over long periods of time, these stellar motions slowly reshape the patterns of the constellations that humans have recognized for thousands of years. For example, the familiar shapes of constellations like Orion or Ursa Major will gradually change over tens of thousands of years as the stars within them drift through space in different directions. This means that the night sky seen by future civilizations tens of thousands of years from now may look slightly different from the one we see today, even though the stars themselves remain part of the same galaxy. While the sun continues its journey around the Milky Way, the solar system also experiences smaller motions within our local region of space. Nearby stars pass relatively close over millions of years, though still separated by vast distances. These encounters are usually gentle and rarely disrupt planetary systems because the distances between stars remain enormous even during relatively close passes. Far into the future, the sun will continue its orbit around the galaxy long after many changes occur on Earth. The continents will continue drifting across the planet, the climate will evolve, and the forms of life on Earth may look very different from those that exist today. Eventually, billions of years from now, the sun itself will begin to change as it slowly exhausts the hydrogen fuel and its core entering a new stage of stellar evolution. Yet long before that distant time arrives, the solar system will continue drifting through the Orion Arm carried by the motion of the Milky Way itself. And while we rest on Earth beneath the quiet glow of distant stars, our sun moves silently through the galaxy, following a path that has already taken billions of years and will continue far into the future, as the Milky Way gently turns through the endless darkness of space. Beyond the vast disk of the Milky Way galaxy, and far outside the halo of ancient stars that surrounds it, the universe continues with countless other galaxies scattered across enormous distances of space. Each galaxy a great island of stars drifting quietly through the cosmic darkness. Although the universe contains billions of galaxies, the Milky Way is not completely alone in its immediate surroundings. It is part of a small collection of galaxies bound together by gravity known as the local group, a quiet neighborhood of the universe where several dozen galaxies slowly move through space under their mutual gravitational influence. The local group stretches across roughly 10 million light-years and contains more than 50 known galaxies. Most of them are small dwarf galaxies containing far fewer stars than the Milky Way. Yet together they form a loose family of galaxies slowly interacting with one another over billions of years. The largest neighbor of the Milky Way within this group is the Andromeda Galaxy, a massive spiral galaxy located about 2.5 million light-years away from us in the direction of the constellation Andromeda. Andromeda is actually slightly larger than the Milky Way and contains perhaps 1 trillion stars, making it one of the most prominent galaxies in our cosmic neighborhood. On clear dark nights far away from city lights, the Andromeda Galaxy can even be seen with the naked eye, appearing as a faint, elongated patch of light in the sky. The light reaching our eyes began its journey more than 2 million years ago, long before modern humans existed on Earth. Another important member of the local group is the Triangulum Galaxy, also known as Messier 33, a somewhat smaller spiral galaxy located about 3 million light-years away. Although Triangulum is less massive than both the Milky Way and Andromeda, it still contains tens of billions of stars and contributes to the complex gravitational interactions within the local group. Surrounding these larger galaxies are many dwarf galaxies, much smaller systems that often contain only a few million or a few billion stars. These galaxies are frequently found orbiting the larger members of the group. Some of these dwarf galaxies are gravitationally bound to the Milky Way itself, slowly orbiting around it over enormous periods of time, while others travel through the local group influenced by the gravity of several larger galaxies at once. Over billions of years, galaxies within the local group slowly interact with one another, their gravitational fields gently pulling on each other, altering their paths through space. These interactions sometimes lead to smaller galaxies being gradually absorbed by larger ones, their stars spreading out and becoming part of the larger galaxy's halo. Evidence of these past mergers can still be seen in the Milky Way today, where faint streams of stars stretch across the sky, representing the remains of dwarf galaxies that were pulled apart long ago. The relationship between the Milky Way and the Andromeda Galaxy is particularly interesting because the two galaxies are slowly moving toward each other at a speed of about 100 kilometers per second. Although the distance between them is enormous, the gravitational pull between these two massive galaxies will eventually bring them together billions of years in the future. When that distant event occurs, the two galaxies will begin a long process of merging and reshaping each other's structure, their stars gradually redistributing themselves into a new combined galaxy. This event will unfold slowly over hundreds of millions of years, and despite the dramatic scale of the collision, the enormous distances between stars mean that direct collisions between individual stars will be extremely rare. Instead, the galaxies will pass through each other multiple times, gradually forming a larger galaxy whose shape will be very different from the spiral structures we see today. For now, however, the Milky Way and its neighboring galaxies continue drifting quietly through the local group, slowly orbiting within the larger gravitational structure of the universe. And while our solar system follows its gentle path through the Orion arm of the Milky Way, the entire galaxy itself moves through space as part of this small cosmic community, surrounded by other galaxies, each shining with billions of distant stars across the vast silent darkness of the universe. Surrounding the Milky Way galaxy, there exists a collection of much smaller galaxies that travel through space while orbiting our galaxy under its powerful gravitational influence. These smaller systems are known as satellite galaxies, and they form a quiet outer population drifting around the Milky Way across vast distances. Just as planets orbit a star and moons orbit planets, galaxies themselves can also have smaller companions that move along enormous paths around them. The Milky Way is no exception, and over time, astronomers have discovered many small galaxies slowly circling our own. Most of these satellite galaxies are known as dwarf galaxies. They are much smaller than the Milky Way, containing anywhere from a few million to a few billion stars, rather than the hundreds of billions found in our galaxy. Although they are smaller in size, these galaxies still represent enormous systems of stars, gas, and dark matter, slowly evolving as they orbit the Milky Way over billions of years. Two of the most well-known satellite galaxies of the Milky Way are the Large Magellanic Cloud and the Small Magellanic Cloud. These galaxies are visible from the southern hemisphere of Earth, appearing as faint cloudy patches in the night sky. The Large Magellanic Cloud lies about 160,000 light-years away, while the Small Magellanic Cloud is slightly farther at roughly 200,000 light-years from Earth. Both of these galaxies contain active regions of star formation, where large clouds of gas continue collapsing to form new stars, illuminating the surrounding space with glowing nebulae. One particularly famous region within the Large Magellanic Cloud is the Tarantula Nebula, an enormous star-forming region, so powerful that it is one of the brightest nebulae known in the entire local group of galaxies. The Magellanic Clouds are not only orbiting the Milky Way, but they are also interacting with each other through gravity, forming streams of gas that stretch across space between them. Astronomers have observed a long ribbon of gas, known as the Magellanic Stream, trailing behind these galaxies as they move through the outer halo of the Milky Way. In addition to the Magellanic Clouds, many other dwarf galaxies have been discovered orbiting the Milky Way, though most of them are much fainter and more difficult to observe. Some of these include the Sagittarius Dwarf Galaxy, the Draco Dwarf Galaxy, the Sculptor Dwarf Galaxy, and several others scattered throughout the galactic halo. The Sagittarius Dwarf Galaxy is particularly interesting because it is currently in the process of being slowly torn apart by the gravitational pull of the Milky Way. As this small galaxy moves along its orbit around the Milky Way, tidal forces stretch it apart, scattering its stars across long streams that wrap around the galaxy. These stellar streams form faint arcs of stars that can still be traced across the sky, providing clear evidence of how larger galaxies grow over time by absorbing smaller ones. This process of galactic merging has likely occurred many times throughout the history of the Milky Way. Smaller galaxies have gradually fallen toward our galaxy and been slowly disrupted, with their stars becoming part of the halo and outer regions of the Milky Way. Through these interactions, the Milky Way has slowly grown larger over billions of years, adding new stars, gas, and dark matter from the smaller galaxies it has absorbed. Even today, this process continues as the satellite galaxies orbiting the Milky Way slowly evolve under its gravitational influence. Some may eventually be pulled apart completely, while others may continue orbiting the galaxy for billions of years more. From our position within the spiral disk, these distant companions are mostly invisible to the naked eye, except for the Magellanic Clouds seen from southern skies. Yet beyond the familiar stars of the Milky Way, many small galaxies quietly travel through the outer halo surrounding our galaxy, each one a smaller island of stars slowly circling the enormous gravitational presence of the Milky Way. And while our solar system continues its calm journey through the Orion Arm, these distant satellite galaxies follow their own slow paths through space, forming a quiet outer family surrounding our galactic home. The Milky Way galaxy that surrounds us today did not always exist in the graceful spiral form we imagine when looking at distant galaxies through powerful telescopes. Like all galaxies in the universe, it slowly formed and evolved over billions of years through a long process shaped by gravity, motion, and the gradual gathering of matter across cosmic time. To understand the history of the Milky Way, we must imagine the universe as it existed shortly after its beginning. More than 13 billion years ago, when the first stars and galaxies were only beginning to emerge from clouds of primordial gas. In those early times, the universe was far more chaotic than it is today. Enormous clouds of hydrogen and helium drifted through space, slowly collapsing under gravity, forming the first small structures that would eventually grow into galaxies. Rather than appearing immediately as large spiral systems, galaxies likely began as smaller, irregular collections of stars and gas. Over time, these early structures merged with one another, gradually forming larger and more stable galaxies. Astronomers believe that the Milky Way itself formed through this process of gradual growth, where many smaller protogalaxies collided and merged together during the early history of the universe. Each time, two of these early galaxies merged, their stars, gas, and dark matter combined, forming a larger system that slowly began taking on the structure we see today. Evidence of these ancient mergers still exists within the Milky Way in the form of stellar streams and unusual groups of stars whose motions reveal that they once belonged to smaller galaxies that were absorbed long ago. These remnants appear as faint arcs of stars stretching across the sky, quietly tracing the paths of ancient collisions that occurred billions of years in the past. During these early stages, the Milky Way likely contained large amounts of gas, which gradually settled into a rotating disk as gravity pulled the material inward toward the growing center of the galaxy. As the disk formed, new stars began appearing throughout the galaxy, particularly within the spiral arms where gas clouds became dense enough to collapse under their own gravity. Over time, this process built up the enormous population of stars that now fill the Milky Way, forming the spiral disk that stretches across 100,000 light-years of space. At the same time, the central bulge of the galaxy grew larger as stars gathered toward the core, while the supermassive black hole at the center slowly accumulated mass from the surrounding material. While the disk of the galaxy continued forming younger stars, the outer halo preserved some of the oldest stars in the Milky Way, many of which formed during the earliest periods of galactic history more than 10 billion years ago. These ancient stars contain fewer heavy elements because they were created before multiple generations of stars had enriched the galaxy with the heavier elements produced during stellar explosions. By studying the chemical composition and motion of these old stars, astronomers can piece together the early stages of the Milky Way's formation, learning how the galaxy gradually assembled itself from smaller structures. Even after the main body of the galaxy formed, the process of growth did not completely stop. The Milky Way continued capturing smaller dwarf galaxies that drifted too close, gradually absorbing them and adding their stars to the halo and outer regions of the galaxy. Some of these events occurred billions of years ago, while others may have happened more recently in cosmic terms, leaving behind streams of stars that still orbit the galaxy today. This means that the Milky Way we see today is the result of a long history of merging star formation and gravitational evolution, stretching back nearly to the beginning of the universe. The Sun itself formed relatively late in this long story, about 4.5 billion years ago, when the galaxy was already mature and filled with generations of stars that had enriched the interstellar medium with heavier elements. Those elements eventually became part of the cloud that collapsed to form our solar system, allowing rocky planets like Earth to form from material created inside earlier stars. In this way, the history of the Milky Way is also the history of the matter that makes up our own world, and even our own bodies. Every atom heavier than hydrogen within us was forged somewhere within the galaxy long before our planet existed, and was later recycled into new stars, planets, and life. And as the Milky Way continues its slow journey through space, the galaxy itself remains a living structure, still evolving, still forming stars, and still carrying the ancient history of its formation within the motion of billions of stars spread across its spiral arms.